All right, so now for our next feat of mathematical brilliance, we're going to talk about powers of monomials.
What?
Now, before we get too far into this, I just want to talk about the visual differences between powers of monomials and multiplying monomials. Notice here you have a monomial that is taken to a power. In other words, you have in all of these questions an exponent that is right outside a parenthesis. But if you look at our previous questions, we never had an exponent right next to a parenthesis. That is the big difference, and that is sort of the cue telling you whether you're multiplying monomials together or taking a monomial to a power. That is sort of what you want to look for. Does the monomial have an exponent outside of the parenthesis right next to it? Is everyone with me on that one? Okay. So let's take a look at this. And we are going to dive a little bit deeper into this first problem. What's another way of saying m to the third taken to the fourth power? What's another way to expand that further? Caroline. Okay, m to the third is m times m times m. I agree about that. But what about m to the third taken to the fourth power? Luke. Okay, so we can make this problem look like a multiplying monomials problem. We can do that. So we now know, using our rules of exponents and the powers, multiplying monomials, that m to the third times m to the third times m to the third times m to the third is equal to m to the 12th. Well, wait a second. There's got to be an easier way to use 3 and 4 to get 12. What did we do with the exponents in this case? Someone I haven't called on yet. Alex!
You multiplied the exponents?
I multiplied the exponents. So the rule for multiplying monomials is simply this. A to the x power taken to the y power is going to be equal to the a to the xy power. That is the rule that we are using for this one. I don't want them destroyed either. All right. And so let's go ahead and use that rule to this problem right here. So I have a times b to the second times c to the third, and I'm taking all of it to the sixth power. So what power will my a's now be to? Zach.
Your a's will not be to the sixth because it's the substance to the sixth.
And this a is to the first power. 1 times 6 is?
6.
Okay. So we're now going to have b to the what power? What power? Tanner.
12.
To the 12th power. How did you get 12? 2 times 6. And finally, we will have c to the what power? Campbell.
18.
And how did you get 18th?
Because 2 times 6 equals 18.
All right. It really is that simple. Before we go on to the last problem, I would very much like to show you another problem that will be marginally more complicated. Just a little bit, all right? So I'm going to write this problem out. No, I really do want blue. You do not need to solve it. I want to talk about it first. So let's say we have 4 times Karis, C. And C, what's your favorite single-digit number, Karis?
7.
7. And we're going to take this to the second power. So we have 4c to the 7th to the second power. So applying the rules of exponents, we will now have c to the what power?
14.
It'll be c to the 14th. That was fairly simple. But we still have 4 to the second power. What's another way of saying 4 to the second power? Thank you for raising your hand. Someone I have not called on yet. Bryn. 16. So if you have a number, you still have to take this number to this power. You are only multiplying exponents in this rule. Normal exponent rules apply to numbers. That will not change. And finally, if that wasn't enough, we are now going to blow your mind by putting the two rules together into one problem.
That made no sense.
Whoa! All right. So, we have f to the 9th g, and that is squared, times f squared g squared h.
What?
I know. It's craziness right here. 3000 South Clayton Street,
That's the address? Really?
room 203. All right, so we have an exponent and we are multiplying things together. Using PEMDAS or GMA or whatever you want to use, do we need to deal with the exponent first or the multiplying first? Caroline? That's right. We have to do the exponent first. So we have to apply this exponent to this monomial first. Then we have to worry about the multiplication. So right now, I would like you to just apply this exponent, this squared, to the monomial f to the 9th g. You have 10 seconds. Go!
F to the 18th, G to the 2nd.
You have 5 seconds. 3, 2, 1. Blast off. All right. I have not heard Alex N yet. So Alex N, what did I have 3 Alexes in here for those people who are not with me right now. So, sir, what will I get?
F to the 18, G to the 2nd.
And then, just like any other order of operations problem, I am required to rewrite everything else. Thank you, but that is not necessary. I will answer to Mr. Franke.
I get it now.
All right, so now
Oh God.
you have 10 seconds to multiply these two monomials together. Go.
After 22 to the 4th and 8th. That's what Jack said. Jack will
Oh god.
It took me like 3 seconds to get it.
I didn't hear it.
It's the only response necessary for that.
Oh god.
It's not necessary. You can just call me Mr.
Dad's
Franke.
brain.
All right. 3, 2, 1, 0. All right. Alex, also known as George.
What?
I have troubles with.
Same last name. More.
Yeah. I know. You've gone through a lot of changes. This is the Alex of the show, really. Also known as George.
What's his last name?
Yeah.
Alright, so now it's just the same thing as you did before. So you do F, and then there's 2 F's, and then the other F is 2, so it'd be 20. And G equals 4.
Squared times g squared is g to the 4th, plus 2 plus 2 is 4.
And then there's just H, because it doesn't have anything. So
And so we have now applied 2 rules of exponents in one problem. And again, the thing that will get complicated in the future is when we start applying all of the rules of exponents in one problem and knowing what has to be done first in order to simplify the problem. So if there are no further questions, you have ACE that is due tomorrow, as well as your algebra sheet. If you do not have your algebra sheet, it is by Scales' enclosure. It is multiples of 3. Multiples of 3. Is 1 a multiple of 3? No. No. It is a factor of 3, which is not the same thing.